Hi, students. Uh, I, I think you have to kind of like had tough time during the midweek worksheet because not it is hard. You grab it in a wrong part. So many students requested me for explaining some parts. So I decided to give you a very brand new recording of like 5 to 6 minutes explaining all the unclear parts to you in very simply. Because it was hard, it is not hard in actual physics, very simple concept. But you learn that for the first time in your life. Whenever you learn something for the first time in your life, you feel really taken aback, surprised. That's what happened to you. Let me explain you one by one. Here. So the students wanted to know about what is that least count. In a meter ruler, you can see 0, 1, 2, 3, 4, 5, and continue with 1 millimeter line. With 1 millimeter is the least count because that is the only smallest region marked on it. So this tape, even the it is a meter ruler, so smallest count is just marked as millimeters. So sometimes you find different devices according to their kind of like uncertainty. One of my very good uh, student asked me, I called her very good because she used to send me the answer sheets very instantly. In the last week, she just asked me for extra worksheets and I sent, and but she also got confused about that scale in grams. It was given one somewhere 100 grams and here 200 grams. 5, 6, 7, 8, 9, 10. I didn't draw it along accordingly in the scale, but somehow there were 10 divisions there. Then there were 10 divisions there. So the difference, have a good look at difference is 100 grams. So you divide 100 into 10. So that means each of these marking like 110, 120, like that. The difference between one line is not 1 gram, it is 10 gram. In that way, you have to be really accurately see what it has actually given. Here it is 10 gram per each. So sometimes you will find certain reading like this. The least count will be like 5 something. Imagine like 5 milliampere. Okay, 5 milliampere. Another again 10 milliampere. So it is not marked. You will get marked like 0 and 5, 10, like that. So in between, if there are, sorry, 10. So imagine like only 5 divisions are there. Only 5 divisions are there. 1, 2, 3, 4, and 5. Only 5 divisions. That means each line separation will be 2 milliampere each. 2 milliampere for each. So that means the least count is 2 milliampere. You to understand that according to the reading. So this is baby's thing, not a level thing. You have to just read how many divisions, only 5 divisions for 10 such thing. So one line is 2 million. Right? Like that, you have to read it for what is the least count. Right? Least count means the smallest value between two lines. It's not a big deal. Okay. Now I said like uncertainty. Okay. Uncertainty stands for something like this. If you measure something here, you assume it to be exactly in line with second line. But the problem is sometimes it might not be the second line. If it can lie between the second line, if you enlarge it, sometimes it can be somewhere here, small, little bit smaller than the second line. or sometimes it can be just surpass the second line. So the maximum tolerance range is half of the range. So the normally the uncertainty is half, but I told you to take half from this side, half from the other side. Altogether, you are taking two readings. Why? Because you can look at it from this side and this side. So somehow I didn't explain you the parallax error yet. So I will teach you these things in the right time and the right place. I told you, I am going to rip apart this lesson because if I keep teaching, you will find really difficult. Remember one thing, there are certain teachers, they don't even touch this because this is dangerous. They are not ready to do it because of fear of losing student. I don't care because this student have to have some kind of confidence in themselves to learn things. So here, it is not a big deal. So you have to, you have the tolerance of 0.5 of the previous region. I shall explain like 0.5 from the other side. Also 0.5. The difference is one of the unit. Unit means it can be like millimeter. 1 millimeter is the smallest reading. As I told you in the previous case, in the dial, it is 2 microampere is the range. So the uncertainty is still 2 microampere, right? For the previous case of the 10 gram thingy, between two lines, the uncertainty is 10 gram. That means uncertainty is nothing but the least count of the instrument. I told you to just search that in the YouTube and stuff. I didn't teach you at all. I left it to you to search because physics, this is not home science. You have a part for you to do, right? I always give you challenges because this subject is not a cakewalk. There are certain teachers I just have seen, they teach in some simple way, they just skip the hard parts. No, that is not the way you have to learn the deep into the subject because in MCQs, all the MCQs may grab you by your neck. You have no excuse. So you have to know everything. Right? I'm not hiding anything. That is it. And there was a thing called fractional error. Before that, least count I explained you. Fractional error is nothing but the least count you divide it by the reading. And you multiply, sorry, not multiply, the least count. For example, is from millimeter scale, 1 millimeter is the least count. If you take like a reading of, imagine 20, yeah, centimeter. So what is the least count? Sorry, fractional error. So you have to put this one as 1 millimeter and here reading as 20 by 10, 200 millimeter. Your fraction is 1 over 200. You can leave it like. It's not a very big deal, right? Look at the least count in the instrument, whatever. So apply it here. Take your reading and just substitute over there. That's it. Now the percentage error means percentage error. You just need to multiply this by 100. That's it. You take the fraction into a percentage. You have practiced this thing in your level enough. So that means you get certain fraction, you multiply by 100, you get the percentage of profit, percentage of loss you did. In the same way, percentage fraction of whatever least count and reading, you multiply that by 100, you are getting the percentage error. So the reason is here, I am going to multiply now this fraction by 100 and see what is my percentage error. Only 2 remaining. It is 0.5%. And I told you minimum tolerance of physics. I explained you with gunman pointing at all of the things. So, and it happened. See, my prediction, I'm like a Simpson. So, American president candidate, Donald Trump got a sniper shot. Yes, Satyaman Kiwa. Okay, they were on the practically, see, foreseeing. Practically, when there. So, he missed his target because he was an amateur. So, only the Trump's ear got damaged. Okay. Now, I told you the percentage error only tolerance is 1% for regular physics activity, right? Regular physics activity. So for the least count, you can substitute any least count given there. For millimeter ruler, it is 1%, 1 millimeter. There will be a minimum least reading that we can take without error. I told you in O level, you have used to measure like 3 centimeter, 4 centimeter, like of distances. But you had to pay the price of thinking of the uncertainty of the answer. You get exocycle or inner cycle, circumcycle, whatever thing, not in the amount you are expecting. Why? It is not your fault. It is fault of the error. The error range is very high. I explained you thoroughly about this. So there should be a minimum reading. Okay, and multiply it by 100, and you will get the minimum reading. So for here, minimum reading is about 100 millimeter, or in other way, 10 centimeter. You can measure for regular things, but for high advanced physics applications, you can't measure anything smaller than 10 centimeter because it causes error bigger than 1%. I told you how harmful an error in a high advanced case. Trump's shooting was a good example. It is not physical experiment. In physics experiment, if you get something bigger than 1%, the result is chaotic. Okay, that's it. And also, I will make a very simple, very little video and publish you tomorrow morning regarding vernier scale. I will explain you. It's very simply and short and sweet about from next week onward, I will just put like 5 to 10 minutes following up videos for the upcoming lessons as well after finishing the class. Because in the class, I try to explain thoroughly, and for the first time in the follow-up, so you will have you may have some kind of idea in the class. After 2 or 3 days, your inner mind, that means the subconscious mind, just working on it. So when I teach you in the 10 minutes, you can easily grab it. That's the technique. I will make follow-up videos from next week, even for hard points, not for all the weeks. If you request me to make a follow-up, I will. Okay, I will make a video for vernier scale. It is a very simple, even garage pass thing. Those people know that very well, very well. They use it. Okay. So how about engineering future engineers? If you can't, it's very simple. Okay. God bless you.